Hi team. Okay, this is a year 12 trigonometry question. Comes up in AS, could also come up at the A level end. Let's just have a quick read and diagnose some key information from this question. So balloon is tethered to a peg to the ground, 20-meter string. Okay, we've got that, which makes an angle of 72 degrees with the horizontal. Okay, an observer on this side of the peg. As the balloon notes that the angle of elevation, so it's angle of elevation to him at 41 degrees, and angle of depression looking down at 10 degrees, the horizontal distance of the observer. So what it says, find the horizontal distance of the observer from the peg. Okay, champion. So in these questions, read it a couple of times, trying to get most of the important information out. And the other key thing is to then go on to draw this information in a diagram. Okay, so here we go. First of all, let's just set the scene here with the horizontal. Let's go from there to there. Let's go back here. So line this up. Okay, so that's the horizontal ground, and this balloon is pegged here. Let's just say it's pegged here, about there, and let's just say the balloon's about here. So this makes 72 degrees angle to the ground, and this, let's just say there's a person on this side. Okay, and this angle of elevation to the balloon is 41 degrees, and let's say this person from there to there, angle of elevation going from there to there. So there we go. Let me just quickly now draw this information. So let's call that the P, the peg. So 1 second, let's go. So this is the peg, and the balloon is here. Okay, this is 20 meters string. Okay, and the angle it makes with the ground is 72 degrees. And this is the gadget here on the right of the peg. Give him some hands. Now, the angle of, now when it says angle of elevation here, it's got to be an angle going from there parallel to the horizontal. So the angle of elevation here is 41 degrees, and the angle of depression looking down is going to be 10 degrees. Note that this line here is parallel to the horizontal ground. So that means if we look at GCSE notes on angles in parallel lines, this angle is alternate to that, so this angle will be 10 degrees. Okay, and what we need to find is the horizontal distance from this fella to the peg. So the horizontal distance from there to there, which I'm going to call X. Okay, happy days. We've got it all set up. What we can do now is can further draw another diagram here of this triangle and pull the information and then work out what have we got and which rules we can use. I'm going to go back to using some straight lines. So we've got this point to the balloon going from there to there. Okay, this point here to the gadget from there to there, and the gadget to the peg looking downwards going from there to there. Okay, champion. Now we know that this to the balloon, let's give this some letters. B for balloon, P for peg, and yeah, just call this G for gadget. Okay, so B, gadget over here, 20 meters length from there. Now from that angle going down, that's 41 plus the 10, so that makes an angle of 51 degrees. And note that this angle of depression, this angle there is the same as that 10, so we must take the 10 off the 72, which will give us that as 62 degrees. So 62 plus the 51 gives me 113, and if I subtract that from 180, so 180 take 113 will leave me 67 degrees. This angle here. Let's call this side here y. We need to find what y is, and what we have got here is a pair of values. Okay, these two are a pair, and these two are a pair. So if we've got a pair of values, we use the sine rule. Okay. Sine rule, as you know, is a over sine A equals b over sine B. So in here, because we want in the side, we're going to put y over sine opposite that is sine 67 degrees, which is equal to, if you look over here, that's going to be 20 over sine 51 degrees. Now what we need to do is find y, so we need to just take this sine 67 to the other side. The way we do this is that's being divided, opposite division is multiply. That implies, as you guessed, y equals 20 multiplied by sine 67 all shared by sine 51, which means sine is equal to, now if you all just do that on your calculators, join me, get your calculators out, get the fraction button going, put 20 times sine 67, don't forget to close the brackets at the end of the angles, all shared by sine 51, close the angle, and we get, now let's just do this to two decimal places, so we got 23.69 meters. Okay, so that tells me this is 23.69, which is y in this case. So what I can do now is, I need to go back, let's just draw this triangle out again. So let's go back to straight lines going from, there's the peg to the gadget's head, going all the way up, from the gadget down to the ground, going down, okay, and then from the peg to the foot of the gadget there. Okay, so there's my triangle drawn, P, G, and let's just put this F as the foot of the gadget, which makes obviously right angle with the ground perpendicular. Now we know this is y, which is this distance from the head of the gadget to P, which I'm going to call, which we worked out here is y, which is 23.69. We need to find the horizontal distance from the gadget to the peg, so we need to find what x is. Right, so this angle here also, we know that this is the same as an angle of depression, so this is 10 degrees, as these are alternate angles. And what we got here, typically now from an A-level style question, we've got a nice GCSE style question here where it's a right angle triangle, call that opposite, call that hypotenuse, that's the longest side, and that is the adjacent. No information about the opposite, but A and H is our triangle, which is cosine triangle. There's C for cos here, A for adjacent, and H for hypotenuse. So that tells me if we find an adjacent, in this case we've got adjacent coordinate x is equal to cosine of the angle. So the cosine of the angle is 10 degrees. Don't forget to put brackets on it, multiplied by the hypotenuse, in this case is 23.69 equals, so give me a couple of seconds to just put that in. So I'm doing it 2 cos of 10 close bracket times 23.69 equals, now the answer on your calculator should get 23.33, etc, etc. We just want it to one decimal place, or three similar figures really, so that will be 23.3 meters. So that is our answer. Find the horizontal distance of the observer from the peg. Well, the horizontal distance is 23.3 meters. Okay, sweet. Thank you.